when acid anhydrides are substances when dissolved in water form acidic solutions. So now here we want to know whether our chloride, when we dissolve it in water, what happens here? And I want us to focus on it mainly today, within about the next 5 minutes, and then we hope that you understand. And it's the one that is going to lead us to what I call the bleaching what? Property. So you're going to first look at the reaction between chlorine and water. So what happens here? We want to see whether it dissolves in water. We say that it does dissolve in water in many ways. Okay? So when you have your chlorine, because you say it's a good disinfectant, when you have chlorine here and you add it in water, we say that we are so glad it gives us a mix of two what? Acids.
Acids.
So whenever which acid first gives us hydrochloric acid, and then another one we give it to them which was
Hypochlorous acid.
like that. And these two, what do they give us? They form a pale yellow. This one is colorless, but this one is pale yellow. So whenever you have chlorine gas already greenish yellow, when you add it in water, it's going to form a pale yellow solution. Form a pale yellow solution. Okay? And this mixture here alternatively is called chlorine water. Alternative is called what? Chlorine water, because so I'm trying to say that chlorine
That thing still works.
it still works. So I was trying to say that chlorine, when added to water, it forms chlorine water. But in that chlorine water, when you treat it as you're treating the water in the swimming pool, it's called chlorine water. Why? It contains two acids. One is called hypochlorous acid. Another is called hydrochloric what? Acid. So what happens here? Let me just change slightly here. Oh, that is fine. So this one gives it a pale yellow solution. And now, listen numbers. We are going to look at the role of this guy here in our chemistry. Then, so I'm saying that we have hydrochloric acid and hypochlorous acid. This one gives the solution the pale yellow solution, the pale yellow color. So I'm going to see a pale yellow solution. If at all I don't expose it in air, it's going to stay. This acid here brings about the bleaching power. What's all about bleaching? Bleaching is making some color fade, something to how you make something lose its original color. You get it? So it can make the color of your clothes to be fading and they become so pale. Also, as it's doing that, it also helps us in what? Removing what? Dirt. That's why you find that in most of those bleaching powders or most of our washing what? Soaps, they have that bleaching property. Why? For the bleaching properties brought about by this hypochlorous acid. How does it show this property here? And I want you to listen. Are we there? So you say that what was the first reaction? We have said that reaction in water. We have said that chlorine readily dissolves in water to form a mixture of two acids, which is hypochlorous acid and hydrochloric what? Acid, to form this pale yellow solution. But I'm saying that the bleaching property now, this one here, allow me to take it off. How does it help us to bring about the bleaching powder, the bleaching power? The bleaching power is brought about how? One, remember all these, the dirt that we have that you always find in our clothes is in form of, it's a stain. Dirt is in form of stains. Huh? And those stains always bring about change in color. Stain, is this the spelling of stain? Stain, huh? So when you have a stain, always we see it as a dye. For you to tell that your cloth is what? It's dirty, you see either brown stain or something like that. For us, we call it a dye. How does this hypochlorous acid help you to remove the color that stains there? What does it do? One, I want us to be very careful there. When I add my cloth that is containing the stains to the water that is containing the bleaching agent, which we are calling our hypochlorous acid. Remember that? Please. We are saying that we are putting hypochlorous acid here, and then our cloth containing that, what you call it that. What happens here? This oxygen within this hypochlorous acid, look at this, is the one that is going to have the major effect. That oxygen is very unstable. That oxygen, what does it do? It comes and combines with this dye here. As they combine, the dye plus oxygen, the dye combines with oxygen, and this dye, you know, addition of oxygen, you're going to have what they call unoxidized dye. Unoxidized is not this dye, oxidized dye or stain. If that one is confusing, unoxidized what? Stain. Are we there? And then what is going to be left behind? As I pick oxygen from the hypochlorous acid, I'm going to remain with hydrochloric acid. So, what is the purpose of this oxygen combining with the stain in their cloth? Well, the more this oxygen combines with a cloth, or with the stain, the more this oxygen from this acid combines with this stain on your cloth, it makes it to become heavy. And whenever it becomes heavy, it falls off easily from what? From your cloth with slight agitation. You know what they call agitation? Agitation, that means that the more you squeeze your cloth as you are trying to wash, any slight agitation will make the dirt to fall off very easy. Very, very what? Easy. What happens here? When I have my bleaching powder, which is jig, or bleaching agent, jig here, it contains hypochlorous acid. What does it do? When added to what's containing the dye, what happens? Our bleaching agent here oxidizes. It adds oxygen to the dye to form an oxidized dye. This oxidized stain here becomes heavy and easily falls off from the cloth by slight agitation, squeezing like this. That's why when you're using this bleaching, the almost and what those all of them have the bleaching power. After cleaning them, after using your cloth, as you're washing your cloth, you always, when you're pouring away the water, you see a lot of dirt down there. Hope people have ever realized that, isn't it? Why? Because this bleaching powder, what does it do? It provides oxygen that combines with the stain to form an oxidized stain, which falls off from the cloth by any slight agitation, and it will sit at the bottom of the what? Of the basin as you're washing. But remember, look at this. What will be the residue? I'm going to see this dye here is going to fall down into the bottom of the what? Of the basin. But what shall I remain with? I'm going to remain with hydrochloric acid. Are you seeing that this acid that is remaining behind is very strong? If you look at those people who always wash clothes a lot, maybe your house soaps, what happens? Always their fingers or their hands, they begin to have blisters. Why? Because what's so effective, but it comes with a cost. This acid that remains behind has a burning effect. It burns your fingers, and that's why you always use gloves, or the limit they use what? Like G, or those advanced bleaching powder. Whenever you repeatedly use them, this acid is going to burn all your fingers, and then you'll be full of blisters or white fingers. People lose their nails even. Why? Due to the effect of this acid that remains behind. So what am I trying to say? Yes, someone is having a hand up. Can I listen to you?
I beg your pardon and I die.
Like how?
What you explained, then oxygen combines with the dye.
I'm going to give you the right. I was trying to describe such that by the time when I start writing, everyone will be comfortable with what you have. Huh?
It makes it heavy.
Are we together?
Yes.
So, what's all about the bleaching? So, the bleaching action, I asked you to describe the bleaching action of what? Of chlorine. So, let me even change this one here. Let me change it like this. Allow me to disrupt you slightly. I'll say bleaching action of what? Of chlorine. One. So what are we saying? How does it show its action that it bleaches? One. Here. Yes, so is this one here. It is who? Husna, who? Husna, can you make your okay?
So what is agitation?
Agitation is just like, and it's like tilt. Huh? How do you tilt? Like as you're washing, that is called agitation. Huh? And it's like shaking. Huh? That's what they call agitation.
Okay, thank you.
All right. So we are saying the first point here, when chlorine is dissolved in water. Let me say that chlorine dissolves in water to form a mixture of acids, i.e., what do we call them? Hydrochloric
Priscilla, can you please mute?
As in Shadia.
acid, mix of acid that form a pale yellow solution. Are we there? So saying that chlorine dissolves in water to form a mixture of acids, which is hydrochloric acid and hypochlorous acid, to form a pale yellow solution. Yeah. What gives it the pale yellow color is the hypochlorous acid. Huh? So the equation that is required, chlorine gas plus water to form hydrochloric acid plus hypochlorous acid. It's already balanced. But you're saying, however, yeah, I don't know whether you can see the side. And I need to change this computer to a certain position that is quite okay with everyone. See how it works out. I'm trying to see how it finally can do it.
Thank you, teacher.
Sorry? Are you still arguing? Oh, Lord. Are we there?
Yes, teacher.
Yes.
I can take off that.
Sorry?
And I'm saying that
Yes.
I'm explaining the bleaching part. So the next part, I think this side you cannot see clearly. Yeah? So I'm going to just extend to this level. So, we are saying that how does it remove the stains, the stain removers? How does it remove the stains? So we're saying, okay, I think that's much better. You're saying that here, the bleaching action here, we're saying that the hypochlorous acid provides oxidizing. Can I say the word oxidizes? Is it very comfortable with everyone?
Yes, teacher.
Everyone is comfortable with what oxidizes. Huh?
Yes.
Oxidizes
Yes, teacher.
the dye in the cloth to form an oxidized dye. What? Stain. Huh? Stain. That becomes heavy. That becomes heavy. Becomes heavy. And easily falls off. Falls off the cloth. That is the fall off the cloth with any slight agitation. Agitation. And it's like what? Agitation. Have you understood the word agitation now, everyone? So the reason when agitation is when, hope you everybody use Omo, Nomi, those one, many. When you try to shake a little after soaking your cloth, do they require the same energy to wash this as when you use ordinary soap?
No.
Does it
No.
require the same energy?
No.
Unless
No.
when sleeping does not work is very effectively. Someone is raising up their hand. Asking Leila, make your case, please. Oh,
I was asking on the spelling of hypochlorous.
yes. It's hypo.
Isn't there supposed to be an O after R?
Oh, yes. Thank you. Hypochlorous, yes. I've missed it. So thank you. Hypochlorous acid. It will fall off. Here, this one here, look at this. One. I'll have the high with the hypochlorous acid. Aqueous. What does it do? It provides the oxygen. So the oxygen is going to combine with the dye to form what they call the oxidized dye, oxide, plus hypochlorous acid. I think everyone here can explain to your parents why excessive use of jig, oil, omo, and what is very harmful to their health, to their hands, because after them working properly, they leave behind a very strong acid, which is hydrochloric acid, that burns your hands. So that's why you have that burning feeling. I think most of us have never put omo in our hands and then trying to soak it in water. You feel that burning effect. So that burning sensation that you get is due to this hydrochloric acid. So that's what we have.
True.
And someone is saying, what is a dye? A dye is any stain, anything of color. So my cloth here have the red dye, yellow dye, and what? That's what I call all those things that you get. Mariam, yes, please.
Teacher, I'm asking, like, this hydrochloric acid that is alone, is it better to call it a strong acid or a concentrated acid?
It's just strong. It's not that concentrated. Strong.
Okay, thank you, teacher.
Yeah. Okay. Yes, please. Naroga. Jordana, please. Jordana, are you having anything to say?
Excuse me, teacher. You have just said water and ammonia.
Jordana, your network.
And then you feel that affects the heat.
Huh? Jordana, can't get anything. Yes, can you get electric close by and then you see how you can climb it so fast? Okay, so this is done. By the way, that's why, listen to this. I can ask you to explain why. Please. I can put the question here. Explain why. When chlorine gas is passed over a moist blue litmus paper. It turns it red. And then bleaches it. So this one here, the guiding question here. Explain why when chlorine gas is passed over a moist blue litmus paper, it turns it red and then bleaches it.
I think it's because the gas is acidic.
Oh, it requires a lot of breaking down the matter. All what you have explained is what you're going to prepare. And you see about 6 marks.
Yeah.
Okay. So who is first here to take Ryan?
Teacher, I was just asking, like, so it means that the jig is just made out of hypochlorite acid.
Yes, but to make it more stable, that's such that they reduce on the strength of being having a lot of acid. They rather replace this hydrogen because the hydrogen here makes it so much acidic. So they make it react with calcium. That's why you saw the bleaching powder. They always have calcium. It's calcium hypochlorite. I think I talked about that. Not so. Try to look at the ingredients of all what you have at home. You see the word calcium hypochlorite. So instead of to be a little bit much safer, you rather form a salt because this acid will burn a lot. Okay. So alternatively, that's an alternative way to make things safer. So please, we had who first? Nasimbe. Nasimbe, please.
Teacher, so the whole point is that the oxygen turns the dye colorless.
Yes, yeah. Just makes it heavy, falls off, and then you see the dot down. It doesn't turn it colorless. It doesn't. So it just makes it bleach off, and then yeah. So let me take about this question before I Tracy, okay, you have the burning one. Can you please make your guess? Is it Tracy?
Yes. Teacher, this the whole explanation you've given us, is it about the dirt falling off the cloth or the cloth losing like color, the color getting off?
Also the color going off? Yes, it can make, if at all you don't have any stains, most of them, some clothes, some materials are not, you know, the difference between the quality of the clothes that we wear, it's all about how much the stains, its color is so strong in these fabrics. When you buy expensive clothes, they don't usually bleach. Hope you have realized that. These ones here that are quite of less costs there, they are not given enough time to make the colors to be strong in those fabrics. So when you use this ordinary Nomi and what, they're strong enough to bleach off, to remove, to force that color to drop off. That's why you find that when you repetitively use this Omo and what when you're washing your clothes are going to become too pale. They won't last over 2 or 3 months because they will be already bleached. So that's why
quality.
prefer, yes. Yeah, the quality, everything goes with the cost. You get it? So most of the times people prefer to use some bit of the liquid soap when they're trying to wash, or they prefer ordinary soap. But most people are advanced to the liquid soap. Most of it is a little bit comfortable. Okay, so whenever you repetitively use, and by the sometimes to make the stain stronger, what do? They ask you to use, when you get your uniforms, most of the times, people, to make that color stay for a longer time, you soak it in boiled water. You get boiled water, you put salt, and then you can add some little of the jik or little of the Omo washing soap. It will make the fabric to be a little bit, the color to be stronger in it. That's why people, when they get new clothes, they do that. But now, let me just talk about this one here. This is the litmus paper. Is it also the same thing as the cloth? No. So where there was a cloth, you're going to be replacing the word litmus paper. Why? The first case, we are saying that explain why chlorine gas is passed when it's passed over moist blue litmus paper. Moist, what's the meaning of moist? It means that you have put water in it, isn't it? Moist means that you have put the litmus paper, it is dry, you put it on water. We have carried a lot of many practicals, you know how to make the litmus paper moist, isn't it? So meaning that when this gas that you are passing over meets the water, what is it going to do? Remember, it's an acidic gas. We shall say chlorine is an acidic gas that dissolves in this water, the moist water, the moist litmus paper, to form an acidic solution containing hypochlorous acid and hydrochloric acid. That's what we say. It was our first step, isn't it? So what happens? The acids will turn the blue litmus paper red. The hydrochloric acid will turn it from blue to red. But what is going to bleach it? The hypochlorous acid is going to bleach the litmus paper. Why? Because it oxidizes the what? The red dye, the red color in the litmus paper. It's going to oxidize the red dye in the litmus paper to form an oxidized what? Dye, okay, which is colorless. What turns it to? Oxidized dye. Someone mentioned about colorless. I can put the word here. Colorless. Makes it fairer. Unoxidized dye that falls off from the litmus paper. So can I talk about agitation? No, you don't need to agitate it. For it to end here. I'll say the hypochlorous acid. What does it oxidize is the red dye in the litmus paper to form an oxidized dye which is colorless that falls off from the litmus paper. That's why it bleaches. And you get your marks. You write this equation also. Are we together? What have I said? We have said that chlorine gas is an acidic gas that dissolves in water to form a mix of two acids, hydrochloric acid and hypochlorous acid. The hydrochloric acid turns the blue litmus paper to red, but the hypochlorous acid bleaches it. Why? Because it oxidizes dye, the red color in the litmus paper, to form an oxidized dye, which is colorless, and after that you write that equation. Are we okay?
Beg your pardon?
About what? I'll say that the hydrochloric acid, what does it do? It turns the blue litmus paper to red. But the hypochlorous acid, what does it do? It bleaches the litmus paper. Why? Because it oxidizes the red color or dye in the litmus paper to form an oxidized stain or dye, which is colorless, and then after that you write that equation.
Teacher, does it have it has the same effect on blue litmus?
No, it has the same, but for it, we have to first talk about the entire journey, how it's going to happen. Huh? Why does it turn from blue to red, and then after from red, and then it loses the color? Eh? Are you getting it?
Yes.
Yes, please. Are we good? All right, then. So what else do we have? I mentioned something to do with chlorine water. Dissolves in water to form a mix of two acids, which to form a parallel solution. I think previously I talked about when you allow that solution and you expose it to sunlight, what happens? It turns colorless, isn't it? You remember that? Let me show you what I'm doing. In your notes or your workbooks that you have that funny diagram there. They ask you what is observed. I think
Pale yellow solution turns colorless with bubbles of a colorless gas.
Sure. Eh? So let me talk about it slightly, and then I will talk about two more before we break off. You see the diagram is like this. We have an inverted what? Boiling tube. It is being immersed in chlorine water. Like this. Like this.
You clamp your gas jar.
Gas jar, what do I need to clamp? Okay, yes, I need to clamp it. Let me just have it as, this is a boiling tube, inverted boiling tube. I clamp it. This is how you summarize it so quickly. Yeah? You must have a baseline like that, quickly. So this is the clamp, return stand. Clamp stands for the return stand. We shall have our boiling tube. So here we shall have our chlorine water. And then here, what am I going to allow? I'm going to allow sunlight, UV light, sunlight. We are saying that our chlorine water, what color do we think it's what? Yeah, greenish yellow or pale yellow. Let us say pale yellow. It's a pale yellow solution. One makes it to be pale yellow because we have formed a mix of two acids. You remember that? So the chlorine that we have dissolves in water. The first equation, equation 1, we are saying that the chlorine that we have dissolves in water. So these are things that they bring in. They do diagrams and they find people fidgeting. Chlorine gives us two acids, hydrochloric acid and hypochlorous acid. Hope you remember that. So which one gives it the color? It's this one. This is colorless, but this one is the pale yellow. Not so. On exposure under sunlight, what did we say? This hypochlorous acid, equation 2, the hypochlorous acid here, under UV, under sunlight, you know, ultraviolet rays, UV light under sunlight, what does it do? it makes it to fall of this oxygen because you say this reactive oxygen is the one that bleaches everything. You get it? Huh? So this one here is given off, liberated. I have oxygen going off in form of oxygen, and then I leave behind hydrochloric acid. So how do I balance? This is what? 2. So to make this a 2, I need to put a 2 here. So this 2 multiplies everything through this one here also, and then you have that. So what are you going to observe? The chlorine water is pale yellow, meaning that it has 2 acids, but when you expose it to sunlight, what you are going to see? This pale yellow solution turns, Why does it turn colorless? Because it is being transformed into hydrochloric acid. Turns colorless, and then you see oxygen is going to be going off in form of bubbles. With bubbles, or purposes of bubbles of a colorless gas. That relies on what? A fluid split. Like that. That's how you get this one here. It can carry both equations. Those are what? Each one 1.5. Those are 3 marks. This one measuring the color, half a mark. Turning colorless, half a mark. Bubbles also another complete mark. Bubbles are colorless gas. So 1, 2. So you have about 5 marks about this. So why should we get to fail the 5 marks yet we can know what has been explained is quite too obvious. Please, please you make your case. Gabriela.
Teacher, the video you had shown us some time back, they said that after hypochlorous acid decomposes under light, it gives off nascent oxygen. Is that what needed?
Nascent is so reactive. Leave that one. Please leave that one. Please leave that one. Nascent it means that uncombined oxygen atoms like this, but it's very unstable. It only combines with another one to form oxygen gas. So that is unnecessary. It is just intimidating. Just leave it. We just go with the plain things. Chemistry is very easy when you use plain language. Yes, please. Another. I think I take one hand and then you do something else. Mariam, are you still having anything to say?
Yes, teacher. I'm just asking, how do you write chloride?
Chlorus?
Chloride, how do you write it? No, it's symbol like chloride. Chloride. It's symbol. How would you write it?
This one here, this is called the hypochlorite ion. I think this is called the hypochlorite ion. Hypochlorite ion. So even covered it in something in radicals. We say the hypochlorite and then the chlorate. You know potassium chlorate in senior 1 when you're writing a preparation of oxygen. For it, it was like this, the chlorate with the three oxygen atoms. So this one has one. Alternatively, one can even write it like this. You can write it like this, or you can even end with oxygen. They are all the same. Don't be confused. Both of them, this one and this are the same. So it depends on your preference.
Thank you, teacher. Okay, right. Thank you, teacher.
Okay, so I think about the second reaction, probably, and that would be saying it all. Because by that, I wish that we could cover as many as possible, but I believe that I'll be teaching myself, or might be wasting each other's time. So we rather go with little and then you understand. But I hope that it sticks to the head, because I might go slow, you understand after this lesson, and then the next lesson you have forgotten. So also that's another thing. So now another reaction that we're going to talk about, let us discuss equation reaction with alkalis. Reaction with alkalis. What are alkalis? I can mention the word alkalis and then we can spend a day here. What are alkalis? Anyone to remind us? What are alkalis? Sorry?
Soluble base. Hydroxide, which is soluble in water.
Hydroxide.
Alkalis are soluble bases. Soluble bases. So what should you know about the soluble bases here? All bases. Bases are in two categories. We have those ones that are soluble in water and those ones that are insoluble. For those that are insoluble, they end at being called bases. Huh? Those ones that are soluble, they're given another name called what? Alkalis. But before we talk about what are bases, you should know what are bases. Bases, we say that anything that reacts with an acid to form a salt
and water.
And salt. So this is how we summarize things. Huh? So when you have a base that dissolves in water, what does it form? Bases that dissolve in water, they always form hydroxide. Huh? They form hydroxides. So that is similar to what we all talk about this. What is a base? A substance that reacts with an acid to form salt and water. So bases are either soluble or insoluble. Insoluble, soluble ones are called alkalis, and whenever they dissolve them in water, they form hydroxides. Okay, so what happens here? That is done. Which soluble bases am I talking about? Whenever I talk about alkalis, the strongest ones are always made up of potassium and sodium. That means that either have potassium hydroxide or sodium hydroxide. So remember, please pay attention. Before I put any words, I want us to understand the things here. Because the words sometimes don't make a thing, but the equations can summarize the entire journey. So let me say that I have sodium hydroxide. Alternatively, I have potassium hydroxide. Or what am I trying to see? How do they combine with chlorine? I want you to listen to this. What do you know about this too? Sodium hydroxide, please stop the chat. People are busy exchanging numbers and what. I'll just kick out some people in the lesson. Huh? So here, this guy here is a base. What about chlorine? We say that chlorine is an acidic gas. So meaning that it's going to behave like what? Can you see that? Chlorine is acidic, huh? So it's an acidic gas. So whatever an acid does, also chlorine is going to do. So are you saying that the reaction between these two guys is going to be what? A neutralization reaction, because what is going to happen? Base plus an acid, what do you form? Salt and water. But the only exception that is going to happen about chlorine, it doesn't only form one. It doesn't only form one what? Salt. It forms a mixture of two salts. The same way that it did with what? With the water. In water, it formed two acids, which is hydrochloric acid and hypochlorous acid. But in this case, also it's going to form two salts. One. So where for the first one, instead of it was hydrochloric acid, we shall form sodium chloride, aqueous, plus what? Here we shall form sodium hypo. The other was hypochlorite. So we shall form sodium hypochlorite and then plus water. Plus water. Please pay attention. And then here, what do we get? Also the same thing. Instead of sodium, we put here what? Potassium. Chloride plus, what is the name of this guy? It will be potassium hypochlorite plus water. like this. But under what conditions here? It forms two mixtures, but the conditions are going to be very careful. Please listen to this. For you to form this, fluorine must be dissolved in what? Cold dilute hydrochloric acid. This one here, the test must be cold and dilute. Let me see the first one. We shall have cold dilute alkalis. That is the first situation. When you put it in cold conditions, cold temperatures, and when it is dilute, sodium hydroxide. So meaning that, how would I describe this reaction? Listen to me. What we always put, this is a gas. How do you add it to this? You either bubble it, you just channel it into it. I say when chlorine gas is bubbled into cold dilute sodium hydroxide, chlorine gas is bubbled into cold dilute sodium hydroxide. What does it form? It forms what? Sodium chloride and sodium hypochlorite and water. Okay, the same thing we say when chlorine gas is bubbled into cold dilute potassium hydroxide solution, it forms potassium chloride, potassium hypochlorite, and water. So my question is everything balanced? I doubt. Potassium, we have two of them. So what do I need to do? When I put a 2 here, what happens? So the potassium are all wiped out. Oxygen, there are 2, 1, 1. Hydrogen, there are 2, so everything is balanced. So the only way to balance is by putting it here. Okay. Remember, what are the conditions? How do you describe this reaction? I think there is a technical word that is not going to be mentioned in your article level. It's not the word disproportionate. We shall leave it out. Yeah. Are we good, people?
Yes.
No.
Yes, teacher.
No. Why is
Yes,
the note
teacher.
We are bad.
People saying they are not coping. What are you not coping?
Pardon on the reactions.
I
mean the conditions.
On
the conditions.
The condition must be cold dilute. We have said that when chlorine is added or bubbled into what? Cold dilute sodium hydroxide solution, it forms sodium chloride, sodium hypochlorite, and water. Okay. Alternatively, if it's added to cold dilute potassium hydroxide solution, it forms potassium chloride, potassium hypochlorite as water. But what would happen here? This reaction is so interesting. When you adjust the conditions, what is going to happen? The inside of forming the hypochlorite, look at this hypochlorite, is going to change to a chloride. Do you remember when I was showing you? The hypochlorite is also written as this one here. It depends on your preference. So for me, I'm starting with the O. You can decide to put the O last. It's all your choice. Okay. So what happens here? Someone can write it like this, like I've written, like that. But for the hypochlorite, you must put it in the other order here. The hypochlorite, what is the difference between hypochlorite and the chlorate? The chlorate, for it has 3 oxygen atoms, but it still carries the same charge. This is chlorate. Look at this. That is the chlorate. So now, what is going to happen here? Please listen. When I change the conditions, what is going to happen? Instead of using cold dilute, and I change it to become hot concentrated. If I'm talking about high marks here, chlorine is highly examinable and carries a lot of marks about it. When I adjust the conditions and I put hot concentrated, hot concentrated sodium hydroxide or potassium hydroxide. When I form the same products, what is going to change, members? The only thing that is going to change is only this. Instead of forming the hypochlorite, we shall change to a chlorate. This is the only thing that changes from hypochlorite to a chlorate. So what changes? They all carry the same balance. This so that means that you don't even bother to, you just combine it like this. And this one is also going to change to that. What have I adjusted is the conditions. When you have hot concentrated bases, which is sodium hydroxide solution or potassium hydroxide solution, what is soft similar? Both of them, in both conditions, we have seen that they form the sodium chloride. But what is going to change? The other salt that you form is the one that is going to change from hypochlorite to chlorate. So this one is going to be known as what? Sodium chlorate. Or this one is going to be known as potassium chlorate. So the only issue is going to be coming about with what? Balancing. Look at the balancing members here. Can I pass balance before you note down here? So sodium, we have 2. Oxygens are how many? 4. How can we balance all this? That shall we have? Okay. We have 2. Okay. Sodium 1, 1. This here I have 1. When I first put a 2 here, what do we get? A 2. I'm going to have 2 oxygens. But here, is this number of oxygens to sorted? No. Hydrogens are how many? Oxygens there are 2 here. You have 4. I need to increase the number. And hydrogens. What is the easiest alternative? The easiest alternative is by increasing them. Let me erase them here to be 3, such that I have 6. These are 3 plus this, 3, 6. How can I increase here? This one is going to be very easy. Oxygens, once they wipe out, put a 6 here. Yes. Hydrogens are going to also be 6. What is going to be left behind is what? Sodium. Here, when I put a 5 here, it is going to increase the particles, or rather put a 5 here. When I put a 5 here, 5 plus 1, 6. Chlorine atoms, how many are they? This is 5 plus this one, 6. So how do I make them 6? Put a 3 there. So the logic is like that. Put a 5 here, also 3 here, 6 there, and then put a 3 there. So that's why you balance. That's how you balance them. So my assignment is what? On both, I want you to write for me the ionic equations. Ionic what? For all of the reactions that you have covered today, you must write the ionic what? Equations. From how they react with water. Okay. Write for me all the ionic equations accompanying that. So what have we covered today? We have seen chemical properties of oxygen, and we have said that of chlorine, sorry. We say the first property, how does it react with air? We have agreed that it has no chemical reaction with air. It does not directly combine with oxygen or nitrogen. Next, we talked about reaction with water. Each reaction with water has guided us to what? 1, its bleaching action. So you say that it dissolves in water to form a mix of 2 acids. The first one was hydrochloric acid, and the next one was hypochlorous acid. And we say that the hypochlorous acid is the one that brings about the bleaching ability or the bleaching action. What does it do? It oxidizes, or it gives away oxygen to what? to any stain or colored dye, and after combining with oxygen, it forms an oxidized dye that is either colorless and it only becomes heavy and requires less energy or little agitation to drop from the cloth. You get it? So that's what we say, and also how it bleaches the litmus paper. And we say that also chlorine water. Chlorine water, it is pale yellow because of that hypochlorous acid. When exposed to sunlight, it forces the hypochlorous acid to lose its oxygen, and the entire solution is going to turn from pale yellow to what? Typically colorless, and you see bubbles of the colorless gas. Are we there? And also we have talked about the last part, reaction with alkalis, and we say that there are two conditions. We say that the first condition is cold dilute alkalis, and then the other one is hot concentrated what? Alkalis. What do you mean by alkalis? We mean soluble bases, and most profoundly, to be particular, we are meaning the potassium hydroxide and sodium hydroxide. And the products we have clearly what? Designed them. Okay. So besides that, I'm only entertaining one or two questions, and then we can raise what? We can call it a day. Man shall not live on chemistry alone. Okay. So yes, Najat.
Teacher, the way you conclude for hypochlorous acid with a dye, how do you conclude with litmus paper?
How do I conclude with litmus paper?
Yeah, like when you say dye becomes heavy.
Hey, for the litmus paper, we say that when chlorine is passed over moist blue litmus paper, what happens? Explanation, we say that chlorine is an acidic gas that dissolves in water to form hydrochloric acid that turns the blue litmus paper to red, and the hypochlorous acid that bleaches it. How does it bleach it? It bleaches it how? By oxidizing the red color in the litmus paper, or the red dye in the litmus paper, and becomes oxidized or colorless and drops off from the litmus paper. That's all about it. And you write the equation that you wrote. The litmus paper, you don't need to agitate it. Yes, Ryan? Nabufu? Okay. Okay, so besides that, I think we can call it a day. Anything else, we shall cover it next time. So have a blessed day.
Okay, bye, Teacher Hamza.
Bye. Bye.
Bye.
Bye. Bye-bye.
Have nice future.
Bye, teacher.
Thank you, teacher.
Great guys. Great girls inbox me or Mariam for the group. It's already formed. Please